we'll start. So we'll write for, let's say we are in, let's say where are we is chapter 3 continuation. So what we have done in chapter 3 is, so we have done, let's say, qualitative analysis. Every day I'll spend some time on, let's say, previous classes so that it will be in continuous. So qualitative analysis is the first part that we have done. Second part is quantitative analysis. Quantitative analysis. What we have done is for, let's say, parallel reactions. Parallel reactions. So yesterday we have solved almost 3 problems. This is slightly important and, let's say, slightly difficult also, as I said. So now what is pending is we will do the series reactions. So what is it that we have done in qualitative analysis? What we have done here is, so here what we have done is, so for a parallel and series reactions, how to select a reactor, or if you have a complex case of reaction, how to select a reactor, and then that is what we have done in qualitative analysis, and how to select the temperature profile, and we have solved some temperature profile problems. In quantitative analysis, yesterday parallel reactions we have done, like if you have a parallel reaction, let's say, if you have a CSTR, if you have a reaction, let's say A gives B, A gives C, let's say CA naught is equal to 40, then CA is equal to 4, that means conversion is 90%, then what is CB, what is CC? Similarly, for PFR also, same we have done, same thing. That is what we have done as a part of quantitative analysis. Clear? So any doubts on yesterday's class? Now what if we will do here is today quantitative analysis, but for a series reactions. But for a series reactions, we will do it for a series reactions here. So but similarly here as we have done in CSTR for PFR, here also analysis will be same. First we will do it for PFR or batch reactor. PFR or batch are same because we are doing all this quantitative analysis only for, let's say, liquid phase reactions. So if you have A gives B gives C reaction, and let's take this as case 1. Let's say this is a first order, this is a first order, this is K1 and this is K2. How the concentration profiles looks like? Concentration of A is dropping, concentration of B is increasing and then dropping, concentration of C is something like this. This is A, this is B, and this is C. So this is concentrations with respect to time. So what is quantitative analysis here is, at what time the CB is maximum and what is CB max. So CB will have a optimum profile. So what is T max? At what time the CB is maximum and what is CB max? This is we need to find. So how do you do it? So how to do it? How do you do this one is, first thing is you should get CB as a function of time. First thing is you should get CB as a function of time. Once you get dCB as a function of time, then dCB by dt equal to 0 will give T max, and T max if you substitute back here, then you will get, let's say, CB max. Simple steps. So basically 3 steps. First you should get, let's say, the CB as a function of time. How this CB is a function of time? You should get this one. Once you get CB as a function of time, then dCB by dt is equal to 0. So dCB by dt equal to 0. Then what is T max and what is CB max? What is T max and what is CB max? This is how you should do it. Clear? Now, so we'll do it for, let's say, case 1, and we are doing it for, let's say, PFR or batch reactor. So case 1. Like this, you can do it for let's say multiple cases. Case 1, A gives B gives C. First order, first order. This is K1, this is K2. We are doing it for let's say PFR or let's say batch reactor. Clear? Now PFR or batch reactor is same. Then I will write an equations which is dCA by dt is equal to K1CA, which is batch reactor, but which is nothing applicable for PFR also because batch or PFR both reactors are same. So how do you write dCB by dt? How do you write dCB by dt is dCB here B is product for A gives B, B is a reactant for B gives C. So dCB by dt is K1CA will become positive, K2CB will become negative. So what is dCB by dt is this much amount of B is produced, this much amount of B is consumed. This is what is dCB by dt. Now you need to solve this equation. Solve this equation and get solve this equation and get CB as a function of time. So solve this equation and see get CB as a function of time. Clear? So how do you solve this equation? dCB by dt is equal to plus K2CB is equal to K1CA. Is CA dependent upon time or CA is constant? Is CA depends on time or is CA concentration of A varies with time or constant? Depends on time. How CA varies depends on time is if we solve this equation, how CA varies with time is CA equal to CA naught into e power minus K1T. Now substitute this value here. So now dCB by dt plus K2CB is equal to K1 into CA naught into e power minus K1 into T. You need to solve this equation. Solve this equation. How do you solve this equation? Have you seen this kind of equation solving in your maths? So concept of integration factor. So what is integration factor? What is integrating factor here? What is integrating factor is e power integral p dx is your integral, no? Integral p dx, which is e power integral k2 into dt. So which is e power k2t. This is your integrating factor. So multiply this integrating factor on both sides. E power k2t is equal to, so dCB by dt is equal into K2 into T, which is equal to K1 CA naught into e power minus K1T e power K2 into T. So this is the equation. Now if you multiply this equation, e power K2T into, like, this equation is dCB by dt e power K2 into T plus K2 into e power K2 into T into, sorry, this is CB, which is K1 into CA naught into T. So how do you solve this equation? This is dV, this is U, this is du, this is V. So what do you write is d by dt of CB into e power k to t, which is equal to K1 CA naught into e power K2 minus K1 into T. This is the equation right up to this point. Next step, what you should do is integrate on both sides, then you will get what is CB, you will get some constant right up to this point. So I'm showing the previous slide for some time so that you will write. PFR and batch are same because it is liquid phase reaction. Now we proved some during batch reactor derivation. So I'm showing all the previous slides. So this is latest. Now, how do you solve these equations? I'm going to next page. Integrate on both sides. Cp power e power k to t equal to k1 into e power k1 by k2 plus c. C is constant. How do you find C is at time t equal to 0? Your Cb is 0, no? If you see the profile. Then 0 equal to k1 Ca naught by k1 minus k2 plus C. So this C, if we substitute here, Cb into e power k2t equal to k1 into k2 minus k1. So if you send k to t on both sides, then what is remaining is, and bring Ca naught on this side, then what is left is Cva by Ca naught is equal to k1 by this is mathematical derivation on both sides. This is Cb as a this is what is first step. Cb as a function of time. You don't need to memorize all these equations. No, never. Don't. Because in GATE exam, he can ask the question very differently. Same question may not be asked. But remember the procedure. So everybody is written up to this point. I'll move to next block, next board. So what is next step? Once you get CB by CA naught, T max. What is dCB by dt equal to 0? That is K1 by CA naught. This is what is equal to 0. Then equal to 0. K1 by K2. This side, and I have written. Then what is T max? CA equal to CA naught to T power minus K1 T. That is, we have proved in integration reaction. Integration analysis. No need to remember anything in this derivation. Nothing. Even you should not remember this T max is also. This time is T max, no, because you have integrated it, no, like this is what you got, T max. How do you get CB max? Now, how do you get CB max? Take this T max and substitute in your CB. Substitute your T max in CB max. T max in CB, so that you will get your CB max. Now CB by CA naught is equal to CB max by CA naught is equal to K1 by K2 minus K1 e power minus K1 into T max e power minus K2 into T max. So what do you get after solving this equation is K1 by K2 whole of K2 by K2 minus K1. So if you solve this equation, you will get this term CB max CA naught. There is small derivation here. Small derivation here, which is not important. That is why I not done the derivation. If you want to understand the derivation, which is there in the previous and your one institute material also, but not important derivation. So remember here, this is the graph that you got. CB max, you got T max, CB max, and this is what is concentration of B as a function of time. No need to remember this derivation, remember the procedure. So can you answer this question? When CB will become 0? When CB will become 0? When CB will become, no, this is not 0. I am asking when CB will become 0. Like CB is increasing and it is going decrease, no? So what is CB by CA naught is K1 by K2 minus K1 e power minus K1t minus e power minus K2t. So when this will become 0? When t becomes infinity. That means this graph continues. When infinity time, it becomes 0. So if you have done this one, then we'll go to, let's say, another case. Case 2. I'm just changing the kinetics here. A gives B, B gives C. This is first order, this is 0 order. K1, this is K2. Can you calculate T max and CB max here? Just do this derivation and tell me what is T max and CB max. PFR or batch reactor we are doing. These derivations are different if it is CSTR. So what is this? K1CA K0 into e power minus K1T. So what is dCV by dt? K2. Then what is CA is substitute here. Now, do you need integrating factor here? Do you need integrating factor here? No. Then if you directly integrate, then what do you get? CB is K1 plus C. K1 will cancel. Plus time t equal to 0. CB equal to 0. 0 equal to See, what is C is CA naught. This is what is C. Then, how do you find the dCB by dt equal to, what do you do? K1 into CA naught into e power minus K1t minus K2, which is equal to 0. K2. Then log on both sides. Okay. Substitute this T max here, then you will get what is CV max. So here CA is CB equal to CA naught minus CA naught into e power minus k1t minus k2t. Now the question is at what time CB will become 0? Now if you put CB equal to 0, CA naught minus CA naught into e power minus k1t minus k2t. Clear? Now if you solve this equation, you will get finite value. Basically t equal to not infinite. You will get some finite value. So CB will become 0 here sometime. It is definitely not infinity. Sometime CB, that time, how do you solve this one is by solving this equation. How do you solve this equation is by solving this equation. How do you get this? It is function of CA not correct. But main value you should understood it is not infinity, it is some finite value. Why it is becoming 0 at finite time? Can you, why it is becoming infinity? So A gives B gives C, first orders, CB is equal to 0 when T is infinity. A gives B gives C, this is first order 0. But here, why? Because this B to C is a first 0 order reaction. When B to C is a 0 order reaction, so for 0 order reactions, you will reach, we have discussed in integral analysis, within finite time, you will reach the 100% conversion. So that is why B, since why you are getting finite value, why finite value, or let's say why not infinity, or let's say why. Reason why is why, because B to C is 0 order reaction. Now, case 3. If you have done this one, then we will do another case. What will be case 3? Yes, A gives B gives C. This is 0 order, this is first order. What is CB max? What is T max? Can you try to solve this one? You will get interesting answer here. Once again, you are doing it for PFR or batch reactor here. Can somebody got Tmax? Are you getting Tmax as infinity? Tmax cannot be infinity, no. Tmax cannot be infinity. If you get Tmax infinity, we are getting something wrong. So if you go by mathematical equation, you will get Tmax as infinity, but Tmax should not be infinity, no? At infinity time, CB cannot be maximum because CB profile is something like parabola. That means you should get a finite value of Tmax. So now if you go by mass, you will not get the answer. Just think by logic here. Let's start deriving here. dCA by dt equal to K1 minus dCB. So here CI is not required. Directly I am writing dCB by dt equal to K1 minus K2CB. There is no CA here. So dCB by dt is E plus K2CB equal to K1. What is integrating factor? E power K2T, E power K2T on both sides. So what do you get from here? Differentiation of CB into e power K2T by dt equal to K1 into e power K2T. Clear? So CB into e power K2T equal to K1 by K2 into e power K2T plus C. What is C is minus K1 by K2 if you solve this one. So what do you get finally? CB into e power K2T equal to K1 by K2 e power K2T plus minus K1 by K2. So what is CB is K1 by K2 into 1 minus e power minus K2T. This is what is CB equation. If you So now, if we do Cp equal to K1 by K2 into 1 minus e power minus K2t. So if you do dCb by dt, then K1 into, this is 0, e power K2t minus K2t, which is equal to 0, t is equal to infinity. So this cannot be right, this is wrong. So why you are getting t equal to infinity? What is wrong here? Now if you look at the reactions here, what is the reaction here? A gives B, B gives C. This is 0, this is first order. Okay, if you draw the profiles, what is profile of A? A will become 0. A to B is a 0 order, so it is a straight line. When A will become 0, when A becomes CA naught by K1. Go to integral analysis. So your B increases up to this point. Your B increases up to this point. Later on, why B decreases? Because there is no formation. Later on decreases because there is no formation of B. So here from this point onwards, no formation of B. No formation of B from this point. So B increases from this point to this point up to this point, and it reaches a maximum when it becomes CA naught by K1. So up to this point your A is consuming, no? That is why your B is increasing. Or B is consuming also, but B is increasing because formation of B is higher than, let's say, B consumption. After this point, perfectly, it has to decrease. There is no other option because there is no formation of B. Clear? Then what is your T max is? Then what is your T max is CA naught by K1. So your B profile, this is your A profile, this is your B profile, this is concentrations with respect to time. Your A decreasing is a straight line equation because A to B is a 0 order reaction. So if you write CA naught minus CA equal to K1 into T, this is the equation. This is the equation. Clear? CA naught minus CA is equal to K1 into T. So your A to B is, A is decreasing like this. Now your B increases because A is decreasing means B is forming, no? B increases. At one point of time, B will reach a maximum. B will reach a maximum. Then B decreases, something like this. Then you should get your doubt why you are not getting CA naught by K1 from this integration. Just think about this one. Why you are not getting this T max CA naught by K1 from this differentiation? Why you are not getting? Because if you see the dCb by dt equation, whatever you have written, dCb by dt equal to K1 minus K2CB. This is applicable when T is less than CA naught by K1. Suppose dCb by dt is equal to simply K2CB when T is greater than CA naught by K1. So whatever the profile, this profile is from this equation only. Later on, your decreasing equation has to come from, let's say, from this equation. So basically, your CB is not a continuous function. Your CB is not a continuous function. CB is an intermittent function. This red is one profile and blue is one profile. So that is why you will not get the answer. That is why you will not get this answer. But why you are getting infinity? Because you have predicted this from the red profile. What is this red profile says is B is continuously increasing. So at what point you will get maximum? When T becomes infinity. So since you have predicted T infinity from this red profile, so if you go back to your previous one, what I have written is here dCB by dt is equal to K1 minus K2 CB. This is a red profile equation, no? So here this is a red profile equation. But if I take this red profile and integrate and if I differentiate and find T max, it shows that at T equal to infinity will get maximum. So basically this is not applicable. This differentiation procedure is not applicable. Reason because it is not continuous function. It is not continuous function. So this B is not continuous function. That is why by differentiation we will not get the answer here. So why it is discontinuity? Because after Ca naught by K1, there is no formation of equation. So dCB by dt is K1 minus K2 Cb is up to this point, red point. dCB by dt equal to minus K2 Cb after this point. Clear? So this is not a continuous function. Red is different profile, blue is different profile. So this is not a continuous function. That is why you should not do differentiation here. But from the logic, when A becomes 0, that is the point where B becomes maximum. So what is here? T max is what is T max is Ca naught by K1. So what is Cb max? Is nothing but K1 by K2 1 minus e power minus K2 into T max. If this is what is your Cb max. Clear? So these are all some fundamental questions. This can be a good gate question. This can be a good simple gate question. So these are the three derivations for PFR. I think we are almost 7:30. So if I start CSTR, it takes maybe another 1 hour. Maybe I'll continue tomorrow. So CSTR, we should do these derivations. A gives B, B gives C. Both are zero order is not possible. So 1 and 1. So we will do it tomorrow. Maybe I'll do it one derivation tomorrow. So tomorrow what do we do is, tomorrow we will do this CSTR derivation and then there are some fundamental questions. With this chapter 3 mostly will be completed. So with that one CRE 1 is completed, which is the maximum, let's say, part of the syllabus, 60% of the syllabus. Because if I start CSTR now, so it takes maybe, I need to, by 8 o'clock means I need to stop in between. That is why today I'm leaving, let's say, half an hour early. So we'll start tomorrow. We'll discuss tomorrow. If you have any doubts, then please let me know. So the class sometimes 1.5 hours, sometimes 2 hours, sometimes 1 hour, depends upon, let's say, the topics. I'm going little bit slowly. So because there are many second years in the system. So now the class is over. So we'll start, you open for doubts. So we'll discuss tomorrow CSTR. So in the earlier page, somebody is asking to explain this graph. So this graph is, this is two parts. Up to, let's say, CB max is CA naught by K1, which is from coming from this equation. Later on, this graph is coming from this equation. Any doubts you have from this section? There is no conclusions, let's say, from these three cases. So it is basically, you have to learn how to do this kind of derivations. Somebody is asking what type of questions can be asked in RTD portion. So that we will discuss in non-ideal reactors. So somebody is questioning how to calculate volume of a batch reactor for a given conversion, since we are not having the volume variable in the, we have volume variable, no? In the batch reactor is also, so in the gate question, if it is a gas phase reaction, then volume variable he will ask, no? If it is liquid phase reaction also, we can calculate the volume. It's not like that we can't calculate the volume of the batch reactor. Now, if it is liquid phase reactor, that volume will come out of the integral and you can calculate. So yes, somebody is asking a good question. We don't use CSTR for intermediate maximization, but what I'm saying is derivation point of view. So just derivation point of view, we'll do it. Doesn't mean that we will not use. Any doubts? In this question, how do we conclude the consumption rate of A more? Because formation of B, the source of formation of B will be from A only, no? That is why A consumption, A for consumption will be always higher than B formation. Because it is zero order, how A gets consumed so far, because it is zero order reaction. No? Tomorrow class timings will be same, 6:30 onwards, maybe till 8 o'clock. So we may not follow the same timings every day. So sometimes half an hour early, sometimes half an hour late, something like that. So until CN by K1, the concentration of B increases. It is not linearly because B formation is linear, but there is a consumption also. No? That is why it is not 100% linear. So there is no difference between PFR and batch reactor. Only thing is the batch is a non-continuous, PFR is a continuous. For liquid phase reaction, both are same. So somebody is still asking 4 to 6 timings. I proposed, but so many of the students has class up to 5 o'clock is thing. But don't worry, we will take daily 1 hour or 1.5 hour or 2 hours. We will go slowly and complete the syllabus. So we have enough time now. Till chapter 3, we'll get almost 6 marks. Somebody is asking. So I'm giving more problems only. I'm giving more. Somebody is asking to solve more problems. I'm solving more of the problems only. I'm covering textbook examples. I'm covering textbook backend questions. Yeah, mostly CRE 1 will be finished by tomorrow, chapter 3, but I'll take one more session for the problems. How many days left for the completion? As I told you, that is what it is, 20 sessions course. I think till now 9 is done. So I think we'll take 10 more sessions. Say I will teach maybe PDC and MEB and maybe economics also. I teach 2-3 subjects. Yes, non-ideal, non-isothermal reactors part. Yeah, non-ideal will be part of CRE2, no? Non-isothermal is also part of CRE2.